So, properties of gases. So, when we talk about gases, there are four things that we can measure, right? So, the first one is number of particles. So, this is very easy. You just simply count the number of particles that are in the container. So, if this is your container, maybe you have four particles there, then the number of particles is four, right? And the volume is the volume of the gas, which basically is the volume of the container. Because remember, gas particles are so loosely bounded to each other that basically if you put them in a container, they spread all over the corners of the container, and so they usually take the volume of the container. So if we put those four particles in a 10-liter container, then the volume is 10 liter. If you compress them into a 2-liter container, then the volume is 2 liters, right? So those are the first two. And the temperature is very, you already know temperature. Temperature is measured in Celsius, Fahrenheit, or Kelvin. So temperature is quote unquote the hotness and coldness of something, but obviously there is a better explanation or conceptual framework for that later on we will discuss. But basically gases could have different temperatures. You could have a container in which the gas inside is at 60 degrees Celsius versus another container in which the gas is cooled down to 30 degrees Celsius. So that's temperature. Now pressure is basically how much these particles exert on the walls of the container. So technically speaking, in physics, pressure is calculated by dividing the force divided by the area. Okay? What this means is the force that the gas particles exert on the container, exert on the walls of the container. So you see, the gas particles inside, because they are loosely bounded to each other, they keep moving around, and so they hit each other, they bounce off each other, and also they hit on the walls of the container. So that, as they hit the walls of the container, they create a pressure, a force, right? And then the area is obviously the area onto which the force was applied. Okay, so so this area thing is very important, and you might say that this is, why don't we have to remember another things, right? It's pressure. It's another thing to remember. Why not just remember force? Now, I'll give you an example that would convince you that pressure is very different from force. So, for example, I don't do this at home, but what if I punch somebody, right? I extend my hand forward with 10 Newton force into someone's chest, right? And that would be different from, say, I apply the same force, but I use this, right? So 10 newtons of this versus 10 newtons of this, you agree would end up into two different scenarios, right? And that's because when I have 10 newtons of this, when I do that, I am basically applying the force over this area, which is the estimate of the area of my fist, right? But if I use this 10 newtons of force, when I do that, all of that force is concentrated in this small point-like area. And as you can probably tell, that means this would injure more than this one. So that's what I'm talking about. Remember, in both scenarios, we are using the same force, 10 newtons, 10 newtons. But because the area of application is different, this has an area of application that is much bigger versus this one, then the result would be different. So that's why in looking at gases, we don't remember a thing like force, because force is not really a factor. However, this new um, physics quantity that we call pressure is very important in determining how much the gas affects the container. So again, there are four measurable quantities in the gas. The number of particles, how many particles you have in there. But obviously in my example, I used 4 particles. But since gases are very small, probably in a liter of even air, it would contain millions and millions of particles. Volume, that's the amount of space that the gas takes. Usually it's the same as the volume of the container. The pressure is this new thing which is calculated by looking at how much force the gas particles exert on the wall divided by the whole area of the walls of the container. And then the temperature is simply the temperature that you know, whether the gas is hot or cold, measured in Celsius, Fahrenheit, or Kelvin.